Everyone, welcome. Thank you very much for joining in. I do appreciate, we appreciate everyone joining in to attend the meeting today on the Direct Digital Reservoir Characterization Technology Industrial Affiliates Program Consortium here at the University of Texas at Austin. I'm Michael Pyrcz. I'm a professor in the Department of Petroleum and Geosystems Engineering and also the Department of Geologic Sciences over in the Jackson School, Cockrell School too. My co-lead on this consortium is Dr. John Foster, a professor also in the Hildebrand Department of Petroleum and Geosystems Engineering. And also, John, do you want to carry on?
You're doing fine. Hello, everyone.
Hey, awesome, John. Awesome. And also jointly appointed in mechanical and aerospace, right?
Aerospace, yeah.
I'm sorry, I always mix that up. I apologize.
It's aerospace and engineering mechanics.
Okay. All right. Thank you very much, John. I appreciate that. So what we do, what is the Direct Consortium all about? I would, if I was to summarize our goals, our mission in life, our raison d'etre would be integrated applied subsurface data analytics and machine learning. That's our goal. We're looking at the data-driven approaches to be able to add value in the subsurface. We want to develop novel technologies, practical workflows, demonstrations, documentation, all to enable subsurface data analytics and machine learning. We think that there's a lot of hurdles to full realization of the value of these data-driven fourth paradigm technologies, and we're working very hard to make this practical for everybody. Now, you're going to see we're going to deliver on our promise. We have practical workflows, we have new ideas, we have demonstrations, we have lots of documentation. We're here to support you using these technologies. Our results are broad, that you'll see that there's a lot of different topics we're going to cover today. And we're really excited to be able to share this with you. Welcome to the second Direct Consortium annual meeting. Thank you for participating in what we promise to be, or I hope we can promise, will be our last virtual meeting. I hope that the next annual meeting will be in person, and we'll talk about that at the end of the meeting when people would like to have it. Is it going to be in May next year or maybe the end of summer to help our students be able to attend in person and everybody else? We will be in person, and as we've already discussed, we'll have breakfast tacos and things like that for sure. Promise. We'll promise that right now. Thank you for participating, though. We are excited to share the direct research products, the workflows, the documentation from the last year. And we really do think that we've continued to build on the success of our first year of operation. This is our second year complete right now. And I think we have a lot to show for the time spent and the investment. Of course, we recognize that. What is the goal of Direct? Well, if we talk about subsurface energy and resources, it's all about putting wells in the best locations and maximizing resource recovery. And so that is the massive integrated problem. I'm sure on the call we have geoscientists, we have engineers, we have people who specialize in data science, we have people who work in business and finance and so forth. We have people in engineering disciplines and geoscience disciplines that break up into all types of sub-disciplines. We know it's a massive integrated challenge. We're aware of that. And so we work specifically in reservoir characterization and modeling. You have to get the subsurface right, represent the uncertainty. We work with production data, engineering, as far as what's coming out. I've heard people say before, productions are only hard data. Yeah, that's an interesting way to look at it. It is at the end of the day, the thing that adds value in energy. Reservoir measures and imaging, geophysical, remote sensing, and real-time drilling, monitoring, and control. This consortium attempts to integrate all of these areas through the lens of data science, data analytics, geostatistics, and machine learning to maximize the recovery, maximize the utilization of important resources in the subsurface. We work in the integration of all of these engineering and geoscience topics and areas. Our efforts are to combine the best practice and cutting edge technologies in reservoir spatial temporal characterization and modeling, real-time drilling control, production data integration in forecasting. You'll see that today. You'll see all of these topics today. Reservoir petrophysical measures and geophysical measurements. With emerging technologies in big data analytics and machine learning, and today I promise you will see all levels of complexity, from very fundamental data analytics and looking at data with new lenses of statistics, spatial statistics, all the way up to deep learning. By the end of the day, it'll be very deep learning to solve some very difficult problems. And we think long-standing problems in the subsurface that now are actually being solved in a very nice manner. We want to do all this to optimize value. We could really just describe this as value of the subsurface. Data analytics and machine learning with engineering and geoscience. That's what we're all about. Who leads the direct consortium? Well, you'll see John and I sitting here right now. I'm looking at the list to see if we have Carlos or Eric here with us. I don't see them here with us yet. I and Dr. Foster, we co-lead the consortium. We're the co-PIs, and we have contributing faculty, Dr. Eric Van Oort, who works is a well-known, internationally respected expert in drilling, and Dr. Carlos Torres Verdin, who's internationally respected in the area of geophysics and petrophysics. We work with them in order to address the overall integrated challenge. Now, let me just right now, I'll go through and list the students that you will see today. And I won't say too much now because I'll have a chance to talk about them a little bit more when I introduce them before they speak, or John introduces them before they speak. First of all, I'll just go through some of the PhD students who you'll see today. Wendy Liu is working specifically, actually, Wendy's very interesting. When she started with me, she came to me and she said, I want to do data and I want to work in unconventionals. And so she's been working in a variety of very difficult, challenging problems in unconventional reservoirs, including feature engineering, anomaly detection, spatial temporal geostatistical machine learning type of approaches that account for spatial bias. And you'll get to see that today. You've heard the old adage, garbage in, garbage out. Well, there's bias in, bias out. It happens in machine learning in space. And Wendy addresses that. I'm excited about that. Julian Salazar, working also in the field. Julian, I see you on the line with us. Hey, Julian.
Hello, everybody.
Thanks for joining in. I appreciate that. Working in data analytics, geostatistics, and machine learning for unconventional reservoirs, including, I think these things are going to change the way we look at the subsurface. Geostatistical significance is a great idea. Every time we sample in the subsurface, things are different. It changes. When is it the difference that makes a difference? When is it different enough that we can say, oh, that's a geologic unconformity. The world has changed. Something's different down there. We need to do something different. Julian is addressing these types of very big questions. And so thank you very much, Julian, for attending. Javier Santos, a third-year PhD student. Javier has gone off the deep end into deep learning. I hope that's okay to say. Gone into all kinds of great ideas as far as how can we capture multi-scale the spatial pore structure, how can we capture that and incorporate that at flow relevant scale? We work together with Dr. Perdonovich, and we're trying to take core information, tomography, the pore space, the complexity, the cementation, the grains, their structures, and we're trying to figure out how that impacts larger scale flow. And I think we're getting very close with true multi-scale modeling. It's very, very exciting. Honggong Zhou, actually, I can brag that Honggong Zhou is my very first PhD student when I moved to academia, and he will be finishing this summer. And so this is amazing. This is my first. I've had others that I've co-supervised, but Honggong Zhou will be finishing up this summer. Honggong has carried on the important task in geologic modeling of trying to build subsurface reservoir models that integrate all the available information. But he's done it with the benefit of deep learning. And this has resulted in a lot of great developments. You're going to see today automated variogram modeling. You're going to see methodologies for production data integration. I'm not going to steal Honggong's thunder here, but I think this is going to dramatically change the way we're modeling the subsurface. Wen Pan, also a fourth-year PhD student, co-supervised by Dr. Carlos Torres Verdin. So WenPan is working specifically on how do we incorporate geophysical information. I think many of us who work with geophysical information know that it doesn't inform reservoir relevant scales, not the flow architecture, the flow units. You usually can't see that in most of our reservoirs. And the big challenge we have is how do we go from coarser scale, but great coverage from geophysical to the models that have the heterogeneity we need to predict the flow. WenPan has been working on methods that actually are able to downscale in a consistent manner from geophysical information to reservoir scale, the flow unit scale. In addition to that, he's developed methods that are truly multi-scale constraints on reservoir models. We can say goodbye to the cookie cutter method. Anybody here know about the cookie cutter method? In geostatistics, reservoir modeling, that's what we've done all this time for multi-scale. We build a model, we cut it out, and we put it into the container. But that's losing a lot of information. I think we're going to dramatically change this. Actually, Dr. Torres Verdin is just joining us right now, co-supervisor of WenPan. Dr. Torres Verdin, thank you very much for joining in. I just introduced WenPan and commented on our joint work with him. Jose Hernandez is a second-year PhD student working on data analytics, geostatistics, and machine learning for unconventional reservoirs. You're going to see work today where Jose said, can we take signals using dynamic time warping to map between signals? Can we use that to understand flow heterogeneity, connectivity, when all we have is the injections and the production at individual wells over time in a water flood? And I'm really excited about this because we're learning new things about the overall heterogeneity, how things are flowing through the reservoir using that information. So Jose, you'll get to hear about that shortly. Eduardo Maldonado has been working on generalizable machine learning surrogate models for production forecasting, really trying to use deep learning and figure out in a very fast, efficient manner what is going to be the flow at that new well. And imagine if you can do that accurately, this will dramatically change our ability to optimize well placement in a very efficient manner, real-time feedback, very exciting, but something happened. Eduardo and I were looking at the problem, and what we realized was that accuracy in the prediction is important. We know that. We know accuracy from our predictions is important, but we recognize that the uncertainty for the subsurface is even more important. And when we looked at the problem, we realized that for machine learning, there's been too much focus on accuracy, trying to get the best prediction. So what Eduardo's done, and we just published a paper on it, we're excited to share this, is he's developed a workflow to be able to get machine learning based ensembles, multiple realizations, we would say in geostatistics, that have a good uncertainty. We feel this is a first, and this is going to be a game changer for subsurface prediction because uncertainty is essential to everything we do. Mede Mabadeje is working on novel data analytics and machine learning workflows to address various sources of data, methodological. Oh, you know what's interesting? There's also cognitive biases when it comes to the modeling choices we make in the subsurface. Mede is actually coming up with objective data-driven approaches by which we can detect and mitigate these biases. The first one she worked with is specifically sampling bias, and you'll get to hear about that today. In addition, she's done some really great work on how do we group and decide on analogs. When you have mature data and you're trying to use it in an immature setting, it's important to know when can we deem that that mature data is analogous. Well, Mede has been working on a great objective workflow to be able to decide on analogies, because these are really important to be able to ensure that we have unbiased results. The prior model is often a big part of our bias in the subsurface. Our choice of our analogs is really important. Okay, Akil is supervised by Dr. Foster, and we'll be talking about the integration of engineering physics into machine learning-based flow forecasts. Now, this is really cool, and I'm really excited. John, I'm excited about this. I don't know if you want to say something about it.
Go ahead. Tell me why you're
Okay,
excited.
John, you let me know if I've got it wrong. I'm going to be characterizing your work with a kill here, but I think this is a great idea. We have the capacitance resistance modeling method. I'm sure many people on the call have heard of that method before. It's a fantastic way to characterize connectivity and heterogeneity from a reservoir using the analog of electrical circuits. And what's very cool about it is that we have good data coverage. It needs just to know what is the overall production injection well to well within the reservoir. Now, what Dr. Foster and Akil have done is they've taken this fundamental model and they've encoded it using very good practice encoding, development of packages in such a way that it's completely consistent with scikit-learn. And the idea is that we can now use it within our popular, if anyone doesn't know, scikit-learn is probably the most popular, one of the most popular machine learning packages in Python right now. And so with this available, consistent with scikit-learn, you can include it very nicely into your machine learning workflows. You could use it within your loss functions, which would be really, really exciting. John, did I characterize this correctly?
Yeah, that's perfect. I would just say that I would say scikit-learn is unquestionably the most used machine learning package in the world, not just within Python. But yeah, you get the benefit of including it in pipelines, just as any estimator. You can do ensemble, bagging regressor with it. So I think there's a lot of opportunity.
And you'll notice John and I have had debates in the past because I come from a background of R before I got into Python. And John reminds me from time to time that Python is definitely dominating when it comes to use around the world. Until one day we all end up in Julia, John.
I hope so.
Jack Shao is just completed a master's with us, working in spatial data analytics and causal statistical analysis. Now, today you're going to see, right at the end of the day, Jack has done something really cool. He took consortium member data, in a collaboration, and applied machine learning and data analytics to forecast bottom hole pressure. Now, this is in order to stop or prevent screen out when it comes to hydrofracking. And so we're really excited about this work, and we appreciate Jack's effort in this area. You'll get to see this really nice practical workflow, and you'll get to even see the workflow if you want to at the end of the day. So our team, I hope you can see, is focused on integrating subsurface data analytics and machine learning to improve resource development and decision-making. Thamer is working co-supervised by Dr. Wheeler and working on the integration of engineering physics into machine learning based flow forecasting. And you'll get to see his work going right into the fundamental physical equations of flow and finding ways to incorporate that directly in to our machine learning methodologies. Mahmoud Shakiba will be joining us also, talking about the integration of spatial data analytics into the characterization, the modeling, and the forecasting for fractured reservoirs. And fractures are very common all over the world in many reservoir settings, and they can be dominant part of the heterogeneity for sure. Mahmoud has done a great job at being able to characterize complicated fracture patterns and get them back in the model. And also going into how do we forecast with them. Now, I want to mention here, Mahmoud will be giving like a guest lecture, a guest visit. His work is funded by the BEG from the FRAC Consortium. And of course, I'm co-supervising him with Dr. Larry Lake. So, all right. Appreciation to all of the students. I heard a professor receiving a lifetime award, and they said we stand on the shoulders of great students, and I agree completely from my 4 years of experience in academia. It's the hard work of the students that makes all of this possible, the innovation, the creativity, the energy. It is hard to keep up with these amazing individuals. Start thinking about 2022 internships and full-time hires. I'm happy to report that all of my students ended up with internships, even in the downturn. And so please, if you're considering some of these students, go, talk to them early. If you need a contact information or anything, John and I are happy, Carlos and John and I are happy to provide that so you can talk to the students. They are in high demand because of their knowledge and expertise in data-driven methods and geoscience and engineering. That is the triple point. I won't say unicorn. I don't like that word, but it is a magical combination. Let's talk about housekeeping here. First of all, appreciation to all of our industrial professionals who are joining in today. I see a long list of people joining us from all over the world. To our friends from Japan, we apologize for the terribly inconvenient time, and we appreciate your tenacity and being with us. June, Tomo, I saw you all. If you like, we are happy to host an additional engagement later on with more of your team members covering this content. We're happy to help out. If anybody else is in a terrible time zone, we're happy to help out with a second, set of presentations and so forth. We welcome you to get involved in direct. Please, if you're from a member company, please talk to one of your company's main contacts. Here's the main contacts from Aramco Americas, BP, Jogmac. And so please talk to them about all of the information about as far as getting involved, getting content, getting resources. Guests from other companies are welcome to survey the presentations this year. We welcome you to see what we're doing, but you won't have access to the consortium products, the papers, the workflows, the codes, and so forth. To learn more about membership, please talk to John or myself. We can help out, or Carlos, we can help out, talk to you about that. Student presentations, 20 minutes per presentation, okay? We ask that you allow students to present uninterrupted for about 15 minutes. Now we'll see. I told the students to stay to 15 minutes. I hope they do. We should have 5 minutes after each presentation for discussion. Please feel free to jump in. We hope people will feel very comfortable to do that. And at any time, we welcome feedback and steering. Direct is very responsive to the interests of our industry partners. That is our goal. Breaks, we'll have regular breaks during the meeting. You'll see that. We're going to simulate, even though we're virtual, and we promise this is the last annual meeting that'll be virtual, but we'll attempt to simulate the in-person meeting. In other words, John and I, Carlos, will be here online. Come talk to us. If you want to have a discussion one-on-one, we can go to a breakout room. Not a big deal. Jen can help us with that. Send us to a breakout room. So we're happy to have discussions during the break. Let's make them productive. You can even have a breakout room with some of the students. We will also have formal sessions where we'll have times for discussion. And at the very end of the meeting, you can schedule time to do that. Breakout sessions, we left time after 4 p.m. And at that time, if you'd like, you can meet with any one of us, meet with any of our students. Please contact John, Carlos, Eric, or I to schedule. We're happy to have any discussions, even the days afterwards, of course. Time slots are still available for that. We know many of you are facing difficult circumstances, and we do appreciate your attendance. It's been a very difficult year. We know that. We are working hard. And really, I think one thing we benefited from is that all of our technology is not lab-based. It's digital. We work with computers and code. And so rest assured, the direct consortium was able to function, to continue on with all of our students working remotely, even without access to our regular buildings and locations. We continue to host engagements and to share knowledge. John and I just hosted an engagement. What was that, like 3 weeks ago? With our friends over in Japan. It was a wonderful engagement. They identified a couple of technologies, said, we like those, we want to hear about them. We brought the students in, we held an engagement. We want to do that. We have our quarterly meetings, but we're happy to do engagements anytime. All right, let's just a couple of comments and reporting out here. The consortium results from our second year, sorry, that should read second year of operation. 14 unique student presentations is what you're going to see today. Every time you see a presentation, know this. There is a report, a paper. The paper will describe the gaps and opportunities, previous work, literature review, proposed workflow, demonstrations with realistic synthetic data that you're free to use. Anybody can try it out. We are fans of repeatable research. People can repeat our research. Presentations will have executive summaries, motivation, demonstration, visualization. I told my students to give you presentations that you can take to your managers, that you can present and you can demonstrate the value. So I use tools like executive summaries, and we communicate in value. So I hope that helps you. I used to sell technology within a major oil company for many years. So I understand how you need to communicate to your managers, and we're here to help you. Code. All of our presentations have associated code, well-documented Jupyter notebooks. John and I are quite proud of that because everyone can take what you see today, the images, you can recreate them. You can run them and you can try it all out. We're open to steering. We want to support your adoption, your deployment of these methods internally. Open to steering, we support professional development. We know a lot of your people are learning these technologies. We make a lot of content to help you educate and increase your operational capabilities. Okay, what do we mean by papers? What do we mean by results? Well, here just for interest is a list from the last year of peer-reviewed publications associated with this consortium. Are we productive? We're extremely productive. There's a lot going on in this consortium. The prototype code, as I mentioned, Jupyter notebooks, well documented. I mean that. We have every step explained. We have the code is readable code for the most part. It should be pretty readable. We have lots of illustrations, good figures. These workflows should be very helpful for you to be able to get started, to try the research out, to try it out on your own data. We've really worked hard at doing that. It's all available in GitHub repositories. We will be doing a better and better job as we move along to do all of our updates through GitHub and make it easy for you to deploy the code internally. Consortium results for the first 2 years are available for you. They are available on the consortium website, but I would direct you to the GitHub repository located here. If anybody on the call is from a member company and doesn't have access to the GitHub repository, you're welcome to send an email to Dr. John Foster, right? John, can they just email you or is chat window okay?
I would say email is more likely that I might miss it in the chat window. So
okay,
just email me.
If you send an email to...
It's john.foster@utexas.edu.
If you send your GitHub username and you're from one of our member companies, he can grant you access to the repository. And we think this is really good. If you go to the direct account, which you'll have access to, every one of the talks, you can see them right here, are their own separate repositories. If you go into them, John, I pick yours because this is one of the best. This is really, really great. You go in there, you'll see this is really well done. You have all of the information on how to install, how to use these codes. You have all of the basic documentation, all of the code nicely laid out, examples available for you to try everything out. That's available to you. I want to also direct your attention to at the top here, the annual presentations. We have a table right here with the schedule for today, all of the presenters, and we also have the topics and links to the repositories with the code and the examples and the presentations right here. So everything is available to you to be able to jump in and try this out for yourself. The presentations are all available in this folder right here. You have original PowerPoint slides. I like that because if you want to take this and you want to take a piece of it and communicate it with your managers or show it when you use the workflow, you have access to the raw figures and to all of the text to help you be able to do that. So we want to see you use this work and we're trying to support you as best as we can. All right, that's the resources. There's a lot available to you on the GitHub repository and the website. Quarterly steering meetings. We have regular steering meetings with our consortium members. We share the results. Let us know. We do deeper dives. If you see some of this research and you're from a consortium member company, let us know. We'll come to your company virtually or maybe in person in a little while, and we'll come and present and demonstrate the work with the students. You'll be able to try it out. Direct engagements. These are pictures from a happier time before we had the lockdown, but we do meet in person. We do work with people directly. We welcome people to visit us at the 40 acres. If you have a chance to come to Austin, please come spend some time with us and the students. We welcome that. And we love to visit companies, and we do that regularly. We do a lot of engagements with companies. Dr. Foster and I also do train working professionals a lot, and we'll just throw this in here right here. We taught, what, John, 1,700 working professionals last year alone in 44 engagements. So if you're interested, reach out to us. We're happy to help with education needs. Okay, I'm not going to spend too much more time. These slides will be made available to you. I'll put them up on GitHub right away, so you'll have access to them. I've already talked enough about the technology. Rest assured, we have a plan we're working through right now to move towards the target of integrated subsurface optimization and maximizing recovery and optimizing well locations. We continue to move forward. There are a lot of technologies in the case of unconventionals and conventional reservoirs that are ready for use, and we're excited about that. I just want to make John, I think it's good to make a couple of comments about the hackathon, if I may.
Yeah.
I think it's good to talk about that. John and I hosted a hackathon within the department last year, last semester in March. It was attended by it actually was 100 students with 20 teams. It was really great. We had 2 weekends of students working on a very difficult problem. It was a challenging subsurface problem, a very hard pre-drill prediction or post-drill prediction of production at new well locations. The students, we gave them 1 day of training specifically to focus on data science, feature engineering, and machine learning. And then we let the students go. We had experts from all over industry come in to act as mentors. I think we might have some of them here today. Thank you very much to all of you who helped out. We did mentoring sessions during the 2 weekends. Then at the very last half day, we had experts come in, leaders from industry and tech. And they judged the projects, and the projects were awarded based on the top projects. The Roaring Kitties, high risk, low return, more drilling were our top teams, and Spectral. I know we have Julian here, so I gotta say Spectral team did also very well in 4th place. So why do I tell you about all this? Let John and I know if you would like to be involved in the hackathon next year. Judges, mentors, sponsors, we would welcome companies to participate. This is an awesome opportunity to spot talent. You heard me say that, spot talent, student talent, but also to participate in building capabilities among the students. We think this is driving a lot of students to gain a lot more skills. Let me quote this. We had leaders from Dell Technologies, IBM, Amazon, AWS. And I'll tell you what, we were told by these tech leaders that this was one of the best hackathons they had attended. And so they recognized the students' capabilities. Okay, I'm going to stop talking now. I've ran a little bit over time. We started a little bit late, but we're going to be talking in the morning. The way to break it up is subsurface data analytics, data preparation, cleaning, and feature engineering. Then right after the break in the morning, we'll get into machine learning for subsurface modeling. And then in the afternoon, we get more into the machine learning for subsurface forecasting. And Jack, of course, has his collaborative demonstration we'll give at the end of the day. I'll finish up with some highlights and discussions. All right, I'm not going to talk anymore. I feel like I've talked too much. The students will be able to speak and explain everything as far as their work goes. Let me just stop here and ask, are there any questions from all of that?
Brian Davis here from BP. Thanks for that great intro. Just a quick suggestion on protocol. I understand the reason for giving the students a 15-minute uninterrupted run. Can I suggest, rather than everybody jumping at the end of each presentation with questions, that we accumulate questions in the chat panel as they occur to us during the talk? This, however, relies on you as moderator to keep an eye on the chat panel and give those questions priority at the end of the talk. Thanks.
Brian, I think that's an excellent idea. In addition to that, it allows us to curate the questions, kind of go through them, make sure we're doing an orderly manner. In addition to that, it allows people to strike while the iron's hot. When you think of the question, write it down. So, John, what do you think of that?
Sounds fine to me.
Okay, Brian, we adopt it. The motion carries. Thank you very much for that. We appreciate it. Anybody else, questions or comments?